All right, we're going to do the answers to worksheet 7.2, disk method. And in this case now we're taking this region, and instead of just finding the area in 2 dimensions, we're actually going to have it come out and rotate around a line. In this case we're going to stick with just the x-axis, create a full solid. It's later that we're going to then see what happens if we hollow out something in the middle. But for today, we'll stick with here. So we've got a function f of x, 16 minus x squared, and we're also bounded by the x and y axis. So we put 16 minus x squared in, futz around with the window. We end up with this graph here, starting up at 16, coming down to the x-axis. We're letting both axes be the boundary of it. So here's our region. If we wanted the area of it, we could just take the integral of this function from 0 to 4. But what we're doing is we're imagining this coming out of the screen, rotating around. Kind of think of this as the center axis of that. It comes out, rotates around, and creates a solid, almost like a bowl shape, if you will. So in other words, if we have this here, and here's our function f of x, okay? If I were to take any particular x value, just a random x value, kind of slice it at this part, what I would be looking at is it rotates around it. What I would be looking at is a circle, right? Okay. The radius of that circle would be f of x. So that's our radius here. All right. And so therefore, if I wanted the area of that circle would be pi times radius squared. That'd be the area of this circle. But what we're actually doing is we're saying, well, this isn't just a plain circle. It's actually a very thin disk. Just imagine, if you will, very super thin circle disk coming out of there. And what we're going to say is the dimension, the depth of that disk is dx. So now we can go one step further and say the volume of that disk, okay, volume of this disk would be its area, pi times f of x squared times dx. And so that would be the volume of one of those disks. If we want the total volume of the figure, then what we're going to do is we're going to integrate from the starting x value 0 to the ending x value 4, and we want all of those disks that have a volume of pi times f of x squared times dx. So that's the idea of the disk method, okay? And so for us, we can take that, easily do that on the calculator. I can go math 9, 0 to 4, pi times y1 squared dx. And we get a volume of 1,715.728. Some people will pull the pi out, and then they'll just integrate this piece and then have that times pi, and that's okay too. But I'm going to write it in terms of this here. Okay? So pretty easy. Again, this method is not too bad when you can visualize what it's actually showing you, right? So for number 2, we have a situation here. So we want to get a visual on that. So I'll unhighlight this and highlight here. All right, and we'll expand our x values a little bit. I don't think we need quite that much going on there. So here's what we see. We've got one function going like this and then one function going like that. And we're told that it's bounded by these and the x-axis, and I would assume the y-axis for this part here too. So in other words, it's this region here. Now, what's different about this one is we have this f of x coming like this. This is f, okay, until this point, and then at that point we have g of x coming down to create the rest of it, right? So we don't have like a top minus bottom going on here. What we really have is a region that's defined by 2 different functions, f of x from here to here, and then g of x from here to here. So let's figure out where that transition is. So if we go intersect, enter, 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 the intersection happens at x equals 7. So from 0 to 7, we're going to be using f of x. And then from 7 to, and if we let this equal 0 and solve it out, we would see that x would equal 9 for that part. So that would be that piece of it. So when we rotate this solid and create those circles, the circles have a radius of f of x from 0 to 7, and then the circles have a radius of g of x from 7 to 9. So the volume then, we'll use the same idea as above, it's just that we're going to use two different integrals. One from 0 to 7, which will be pi times f of x squared dx, because f of x will be the radius there, plus the integral from 7 to 9 of pi times g of x squared dx. Because then between 7 and 9, g of x is the radius. Now, if you're thinking, could I pull this pi out and have pi times? Yeah, absolutely. There's other ways that you can simplify this for sure. Okay, but what we're going to do is we're going to use these two integrals. So math 9 from 0 to 7. Go pi times, and this f of x is my y2 in this case, squared, okay, dx, plus math 9 from 7 to 9, pi times, now this time I'll have y3 squared dx, okay, and I get a total volume of 308.3996. If it rounds, it goes to 400. There's our volume then, right? So again, the disk method's not too bad. Just to get a picture what's happening. If I slice it, I'm slicing out a disk. What is the radius of that disk? Then for what's the area of that circle, and put a dx on it to give it some volume, and that's how we create that.